All right. Testing. Can folks hear me? I might need to manually check this. All right. It looks like it's working. This is the start of stream number 3 of combinatory logic in C++. And the first thing we're going to do is we are going to, well, I'm going to take off my headphones because I don't actually need these. We are going to recap some code that I programmed yesterday off stream. And we're going to quickly go through this just to catch people up that have been following along. And basically, I refactored a few things. The main thing that I did was I enhanced this generate combinator spellings function. And on top of that, I added a bunch more combinators to the combinator dictionary, which means that we can generate more spellings. And to recap sort of the enhancements that I made here, I turned the while loop into a do-while loop. And I also added, I realized that we basically have this mask and we're building up strings of length 2, 3, 4, and 5. But they always happen in the order that they exist in this list here. So this loop here basically, actually, wait, where is that loop? There's now like 2 do-while loops. One of them is for permuting the mask so that you get different letters. And the other one is for permuting the order of those letters. And then on top of that, I added another loop that will add parentheses to our strings so that we have parentheses, so that we have spellings with parentheses. And that's kind of it. And then on top of that, I used to be printing out every single one of the combinator spellings, but now basically what I do is I just print out the ones that are of interest to us. And I can sort of demonstrate this. So if we run this code, and let's actually, what do we have this set to? So this should be fine, yeah. If we run, we now get, at the bottom here, you can see basically a list of all the potential different spellings of our combinators. So if we go now back to combinatorylogic.com and we go to our table, you can see, for instance, the W spelling here is C parentheses BMR. But if we go to W, these are supposed to be sorted by, maybe that's what we should add to our to-do list. They're supposed to be sorted by length. To do, figure out why sort by length is not totally working. I mean, I guess it's actually possible. You know what it is? I mean, I already know the answer to this now. Because we're using Unicode, this has like more code points, or I don't know what the terminology is in Unicode speak. But I decided to call the Ki combinator kappa, because I think it's silly that Ki doesn't have an explicit name for itself. So we are going to just name this kappa. And I guess that's why this one, even though it's 3 characters, probably reads as 4 because kappa shows up as like length 2. So our total length of our string is 3. Anyways, point being is I'm showing the shortest spellings up to 10 for each of our combinators now, which is pretty neat. So, hello, Lumi. Thanks for tuning in. The first thing we're going to do is we're going to actually go in and fill in a couple of these now, which do I actually... Oh, that's not what I wanted. One sec. Let's just, we'll hop back and forth here. So this is the code that backs this website. So let's open this up. And let's go to table.htm. This is pretty gnarly stuff. I've been meaning to change this so that it is Markdown and not HTML, but it is what it is for now. So we are concerned with the CH combinator. So, I mean, let's go take a look. I had run this previously too. So if we step back into our main, I had run this basically, it takes a little bit more time. Ooh, that's kind of irritating. Let's just, can we look at the full-blown README? All right, it'll have to do in terms of how big it is. You'll see that B, basically like it looks like at this moment that the best spelling for B is what Chris Rathman has. This SKS. So let's just go add that. I mean, we can update these later if we discover something that's better, right? And however, for W, I think we have a much better spelling. So CSK, I think, is way better than C parentheses BMR. Oh, no, do not do that. Save without formatting. We are going to update this to kappa. And, I mean, identity. Is that true? That KK is the identity? Why would it be listed as SKK? That must not be correct. Let's go, that can't be right. Let's add it to our unit tests, turn off that. Put it near the top. Actually, I should have just copied let's just copy that one. And then let's go and turn on our debugging info and go back to CLPPP build. And so SKK gives us the pattern ACBC, which is going to be KA parentheses KA and then that's going to get dropped, and then you're just left with A. Okay, so that's right. What about KK? K is assigned A, and B is assigned B, or B is assigned A, and then you drop the A. Interesting. I mean, that doesn't really seem right. I wonder if I know on Chris Rathman's site, he has this little except I can't really remember how this works. What do you have? You had JI, ABC. Yeah, that's kind of a bug, right? I'm not sure if anyone's following along, but basically the way my program works is that it tries to match spellings down to function abstractions by associating the combinator with the right part of our function abstraction, aka what's split after the dot. But as you can see here, both K and I have the same substring left of the dot. Well, I mean, what does that mean? Does that mean our program broken? I don't think so. I think it just means that like the path that you take to get to A matters. So like here, the final step right before A is this, AB, which is clearly K. Whereas the last step before we get to A here is not AB, it's something else. All right, we'll kind of ignore that for now. What does that mean, though? So let's go back, turn that off, and turn that back on. I mean, I feel like we'll have to come back to I, but for now we should just leave it as SKK. And then what's next? The C combinator. I believe. I mean, there's got to be something simpler than this, but for the moment, this is what we have. And let's look at B1 now. I'm pretty sure B1, the simplest, is triple B. What's interesting, though, is that for the B1 combinator, they spell it like this, but really, you can spell it more simply like this. Is that going to copy and paste the subscript, though? So yeah, really, these things are equivalent. But for some reason, they choose not to spell this as the B1 combinator in the middle there, which is really what it is. And this is really BBD. Is D in our combinator list? D is not. Let's add D. And that's going to be A, B, C, D. Let's run this again now. We're also going to do some Python programming in a sec. Yeah, so D clearly is BB, but what we want to do though is we want to come up here and add D to our mix. Should we add 2 Ds? Interesting. Technically, now anywhere there's a double B at the front. And then DB1 is actually pretty nice too. I kind of like that. So instead of this, it's this. Instead of this, it's this. And also D needs to be defined as BB. And then what is this? This is Picard, which is B3. We don't have that spelled here yet. And the phi combinator can be spelled pretty succinctly like this. That's nice. And I think this is good for now. We'll come back to this, but let's save without formatting, publish this. Update ch in table. And now we're going to do some Python programming because we'll wait for the website to update. But what we are going to do in the meantime, it should only take a couple minutes, is we are going to go to my plgraph repository, and you can generate these cute little diagrams. But what do I want? I want text only, thesis, and we are just going to copy and paste this. All right, let's go check in on our website now. Oh, it's still not updated. Did I push? I did not push. So now we need to go touch, we'll just call it graph.py. And now we turn into a Python live coding session. I was going to update so I'm pretty sure I don't need any of this stuff. And still not done yet, but we're going to need S, K, I, and let's delete all of these. I think we can delete all of this too. Probably we can delete this too. All right, there we go. So let's just see if we can get this one set up first. So basically what we're going to do is we're going to create a dependency graph. This is just for your label. For combinator in combinator keys. Label equals L, label equals I mean, we can just delete this. And do we even need label for the moment? I think this is a way more complicated script than it needs to be. For combinator, and I don't think we need the style for now. I don't know what this line is doing, but have I ever taken a look at Antling? Is that the language for like creating languages? No, I have not. not seen this before. Looks interesting though. All right, let's see if I got this right though. I mean, if I got this right on my first shot, it would be pretty amazing. Pip3 install. Graph is this not going to work because I don't have some dependencies? Let's just see if I open a new WSL. Do I need this? All right, let's go troubleshoot this for a second. Okay. Gotta love Stack Overflow. I mean, how do I open a PNG on WSL2? Do I open a PNG on WSL2? I don't think that's... I'm not in PowerShell. That's not what I want. EOG for WSL2. I don't want to have to. I mean, I can open this in VS Code, right? I mean, that's the hack. Waha. Is that what we expect, though? I is based on S and K. Oh, I messed this up, though. I'm going to go fix that. Kappa should be in my column. And actually, what we really want is, we just want this to be named kappa. And actually, I prefer the definition, not KI, I think CW. Or it's not CW, it's CK, right? If we look at kappa, yeah, CK, it's just applying the swap or flip combinator on K. So instead of dropping the first, or instead of dropping the second, you're dropping the first. So, oops. Save without formatting. Let's go small fix. Go back to CLPP. And now we want to update this. So now this works. The style is fine. What I kind of want to, I want to do two different things though. I kind of want to, can you like, can you do this? I kind of want it in a smaller font. Python 3 graph. Yeah, it does work. That's good for now. I mean, we'll make the font smaller later. Let's go back to our website now. Is it updated? It is updated. So now we can add kappa, which depends on C and K. Which depends on C and K. I guess we need to add C then. Hey, I've just been watching your videos for a while. I just wanted to say thank you for all your work. I hope that one day I will become as great a programmer as you are. Well, thanks for saying that, Dominic. I'm sure with time you'll get there. So what is C? I mean, let's actually leave this off for a sec and just see what, see where this gets us. Interesting. Oh yeah, and we got to do the. We got to do the /n definition. Interesting. So it already added C, even though we don't have that yet, so that's good. Let's add W as CSK. Actually, do I have? I don't. Code align. Should we go download it right now? Where is I just need to get her to what is it called? It's called code align. I think this is it. All right, back to this. And so now I can go align by regex. Waha, look at that. And then this is going to be C, S. Why do I have an alarm set for 6:35? Turn that off. Now we can generate our graph again, come back here. Of course, I don't know how to get to this without doing that. It's a pretty looking graph. Let's add the B combinator. So B is SKSK, and then B1. And this is why we added code align, because now I have to do this. I mean, technically I could just, each time I do that, do the multi-line thing, but, and this is going to be SK, and then if we do B1, it's DB. And if we do D, it's just B. Now what's that going to look like? Why did my subscript not show up? Let's go get the subscript. That's sad. These are all disconnected. Let's connect them. All right, I didn't rerun it. And I also forgot to add the definition. So B1 is it DB, and D is BB. And if we come back here, what are we left to connect these? I guess C definitely connects it. And so does Phoenix, so let's go do that. Now when we look at this, they should all be connected. It's kind of boring, to be honest. I thought it would be a little bit fancier. Oh, but we haven't added B. That's why. I thought we did add B. We didn't add B. This will make it look more interesting, to some extent. How much more interesting? We're about to find out. What's going on? B. Oh. You see what's happening here. Let's go. Yeah, so what's happening is that because we're using different keys names, it's not actually linking them up. That's why it looks so boring. So let's do this. Let's copy and paste this for now, comment it out, come back to it later. And then then we go This is going to make things way more exciting. What did I do? Phi. Perhaps you forgot a comma? I did? Where? Oh yeah, I did. Wow. Much more exciting. And if we add C, it'll get even more exciting. So let's go add C. Update that later. Wow, look at that. Isn't GraphViz friggin' awesome? So this is the kind of the interesting thing looking at this, right? I prefer the CK spelling of kappa, aka KI, but it would probably make the graph look nicer if we just use the KI spelling. Because kappa doesn't really belong all the way at the bottom there. It's just like a, you know, it's just a flipped K. So we will go and agree with, so if we change this now, run this, see now kappa is now all the way up here, which this visually is nicer in my opinion. Which means we need to go update, our spelling to be KI as well. I find KI so much less intuitive when thinking about building that combinator. We should add B2 and B3. I just love though. It's such a beautiful graph. I still feel there's like better spellings of C and W. But the fact that like S and K are the two fundamental, you know, SK combinatory logic. I mean, it links to SK, but I'm sure very quickly, blah, 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 blah. I mean, let's just search for SKK. Yeah, so it says, from these definitions, it can be shown that the SKI calculus is not the minimum system that can fully perform computations of lambda calculus, aka be Turing complete, because I can be replaced by SKK or SKS or SK whatever. Yeah, this is the whole K duplicate thing, right? Because the first K is gonna keep, actually, yeah, I have to think about that some more. Anyways, this graph just kind of shows that. But let's keep going. We still have B2. B2 is DB1. Should we add B3? I mean, B3 is not even in our table yet. A, B, C, D, E, F dot A, B, C, D, E, F? Is that the definition of it? Well, it's actually not. It's A, B, and then in paren CD. Actually doesn't even have an E. Not what I expected. But we need to go and get subscript 3. And then we need to add and now we got to run this again. What happened? Oh. How all of that got generated from a missing comma. Nobody knows. So B3. And I think this is actually the definition that Chris Rathman uses. The B paren BB and paren B. But we're going to use BDB. Let's go check on the site. Yeah, B3. So we're basically using the same thing. We're just using a D instead. And we will... Is this B3? Yeah. Come back here. Add... I don't think that's going to change our graph too much. Ooh, actually kind of made it look worse. Switch the S and the K around. And let's go... Let's go push that. Phoenix is B1 SB. I mean, and does this like I definitely like this definition better than this definition. Is this definition better than this one though? And that's the thing, we don't actually have dual parentheses, we only have searching possibilities of one set. So yeah, now we've got the same thing here. So really we've only made an improvement on, I guess we made improvements here by using D. And we've added Phoenix, which didn't even exist before. That's definitely an improvement. And are these going to just be BD? I guess we should add these ones. What did you miss? Not much. I guess, have we been streaming for almost an hour already? Wow. We recapped some changes that I made offline yesterday. And since then, we have been, I guess we created this graph to sort of represent the dependencies of the combinators that we're filling in the fifth column of this table. And most of them are the same. In my opinion, W is an improvement. The B subscript combinators are slight improvements. We have a definition for Phoenix now. We technically also have one for psi. If we go, let's go back to, so when I ran this before, I did get this one, which is kind of yucky. But we can add it. And then maybe we should, I still think that there are improvements to be made though. I definitely think we can improve on this. And yeah, we need to improve on this because I really want this definition to be CK, not KI. The problem is because C's definition is so complicated, it ends up down here, and then anything that depends on C is going to end up below it. But really, I want C to be near the top. And there is actually a system called the BCKW system. Yeah. So this is another one. Before Haskell-Curry figured out that SKI and SK were like the fundamental calculuses, he was using this one for a long time, the BCKW one. And it was published in his dissertation. Although I thought his dissertation was published in 1931, not 1930. In fact, let's fact check that. I don't believe that this is Wikipedia is wrong here. Or maybe I'm wrong. Although this is not his dissertation, so I'm just, he had a paper in 1930? Really? I know he had his paper in 1929, an analysis of logical substitution. And then, yeah, his dissertation was in 1931. So I guess this is not, I don't speak German. That's the problem. Let's go figure out what's his Haskell-Curry dissertation. Yeah, his early ideas were 1929, analysis of logical substitution, and then this one. What's his dissertation? Shouldn't be that hard. I mean, that is the English name of it. Anyways, back to this. So what were we gonna do? We ultimately are gonna try and find a simpler one for this. In the meantime, though, let's add psi. So psi is this guy. Oops. Whoa. It's kind of ugly. Oh well, what can you do? And let's go and do the... Julian says, trying to understand, you have a few combinators and trying to see and visualize how you can build all the other ones from those? Kind of, yeah. I mean, yeah, I would use the word spell because build is a bit ambiguous. In that you can like fix certain functions of other combinators to build other combinators. For instance, like the phi combinator, when you fix one of the unary operations to be the I combinator, you end up with either the S combinator or the sigma combinator. Here, though, we're doing something completely different. We're just trying to say what combinators are required to spell them. It's a bit amorphous, though, because there are multiple ways to spell these, right? Earlier I was trying to talk about how I prefer the spelling CK to KI because I think KI, when you walk through this, you kind of have to like mentally, you have to do mental gymnastics. KI, yeah, even right now, like thinking about it. So KI, B, and it keeps the I, so it's like you have to go KI, AB, and then K is going to drop the A, and then you're left with IB, and then I of B is just B. So for this whole function, if it takes two arguments A and B, you're given back B, which like, sure, I can do the mental gymnastics to understand how the KI spelling is the kappa combinator, as I'm calling it. And this is like, to make this a little bit more... so this is like the equivalent of... so the I combinator is id, and the K combinator is const. So if you give it two numbers, 1 and 2, it gives you back the first one. So you can go const id 1, 2, and then get back 2. But like, what is this doing here? What this is doing is it's evaluating this first, keeping the identity function, dropping the number 1, and then you're left with identity 2. Whereas in my opinion, the C combinator is called flip in Haskell. And if you just do flip of const, what that does is it takes this function and just like flips the arguments. So now instead of keeping the first one, because you swapped the arguments 1 and 2 to be 2 and 1 behind the scenes, you're now keeping 2, which is the first one. And I think this is much more easy to understand. Like there's less mental gymnastics involved, because in Haskell, flip is like a bread and butter combinator that you reach for when you want to swip the argument order. Whereas like composing const ID so that you can throw away the next thing that's passed to this series of functions, then to just keep the second one, I think is just confusing. My point being is that I would like this to be CK without it making the graph look awful. But in order to do that, we need to simplify this and therefore, discover a nicer way to spell this. But that, we'll leave that for a later date. Right now, we're just kind of building up this. So right, we were in the middle of adding psi. We did add psi. That kind of messed our graph up. And so let's go add, I guess so we should go and add that to our, where did it go? Yeah, we want that. We want to add this to that. So yeah, let's go add the D1 and D2. Also, is that actually showing up correctly on the website? Yeah, so I don't even need to do that sub stuff. That's silly. Let's change that right now. Is there a B2 here? Yeah, I guess we'll fix it later. So this is A, B, C, D. What should we call this one? Let's call this one Y. And let's see what happens. Yeah, as expected, it's just the same thing, except we replaced the double B with D. Which I don't think should do too much to our graph. But let's see. Huh? Where is D1? Oh. Messed that up. Wow, never mind. I was completely wrong. It changed our graph immensely. Interesting, too, that I don't have I in our source, so nothing depends on I except for kappa. Which also kind of is like, leads me, I really want kappa to be CK. Let's do a tiny test here. What happens if we go down here? What if we add an I? Yeah, we're using GraphViz for Python, or Python for GraphViz. And wow, that's kind of cool. And very interesting, except we can't have B depend on D because D is double B, so that would be circular. That's also interesting. I still like CSK better. SS kappa. SS kappa for W. Let's check that. For W, let's try basically the same thing as oh, except it should be kappa, not K. Good thing those characters don't look identical to each other. Let's kick this up to 5 for a second. This is going to take a little bit longer to run. Huh? How long is it going to take? Should we time it? Well, it was already running for like 10 seconds before. I'm kind of shocked that this actually works. I want to investigate that for a second. and I guess I need to turn on I don't have phi in my combinator dictionary. Right, because it's p, not phi. IABC. Well, it's pretty cool. Yeah, I guess that is right. All right, we were trying to get. I mean, let's take I out for spelling, and we added D1, and I think we just need to add D2 now. And so this is BD, right? Let's go update that. So D2. Is dict of combinators you made in Python. Oh yeah, I can push it right now. Or here, let me just add this last thing. Call this X. And then we want, because this is D2, call this D2. Just make sure, oh yeah, and we also want to comment out this stuff. D2 is DD. What do they have? Yeah, I guess that's the same thing once again. All right, let me go update that. And then I'll push. Oops. All right, the website's updated, and if we come back here, let's move. Move that. Oh yeah, we can actually go get rid of that comment. We know why this isn't working. We've added the PLike thing. Looks all good to me. Actually, let's go delete that unit test as well. And let's actually just go look at this file. We don't even need, it's too complicated, it'll make it too messy. Let's just make sure it works still. I guess we didn't add D2, but that's fine. I'll do that in a sec. What is Q? Add graph.py and small changes. All right, you should be, oh, we got a poll. You should be able to go pull it down and play around with it now. Now let's go add D2. Probably gonna stream for 10 more minutes. And I think this is just DD, right? If I recall. Is DD? Oh yeah, so we can go check. This website should be updated now. And yeah, let's run this. No, it's getting worse and worse. So now let's actually go. Let's see, we've got X, E, Y, H, F. Interesting. Can't remember if that one was there before. Doesn't really look like that changed too much though. Is there anything else we should do? I mean, so what's left to do is simplify this and simplify this. otherwise, kind of, these are mostly the same. Oh yeah, that's what we do need to do though. Need to come here and nope. Didn't we just copy this? What the heck? Ooh, I kind of like that one better. Copy. What's going on? Why is it not? I mean, I guess it's already here, right? That'll work. And while we're at it, I guess I should say Python and rename this video. There's the I mean, anything else we should do? Can't really think of anything for the moment that is doable in like 7 minutes. I mean, so the question is what are the final steps to simplifying this? I guess maybe adding a second set of parens. Or just expanding what are we missing? Missing Q, M. Yeah, I mean, it doesn't even show up if we don't expand it anyways. The upper bound. I mean, I guess that's what we can do in the last 5 minutes of the stream. I can't remember how long this took to run though. When we kick this up to 6. Could take a couple minutes. I know I ran it the other day and it took a while. Any questions while we wait for this to run? There is a question. Do you think functional programming could ever be as fast as imperative, or is it theory limit and not more research? I mean, I've actually talked to Sean Parent about this, and his thoughts are that, one, people just think inherently imperatively, so it's harder for them to grasp functional programming. I think it's possible, though. You could make an extremely performant language. I mean, arguably, Rust is a quasi-functional programming language, and it's competitive with C++. And Julian asks, when you say simplify, what's your criterion? That's a good question. I would prefer it that if we open up this graph, I would prefer it so that it's simpler, because right now the two most complicated are C and Psi. And because of that, that's where you get these long swooping arrows down here. Whereas, in this kind of B family of combinators, B subscript and D subscript, if we got rid of everything, in fact, we can do that while we're waiting. If we got rid of everything other than those, it's going to look really nice. Again, can guarantee you that. And, except we're going to need another WSL2. That's not what I wanted. Python 3 graph. I mean, I wish that S and K wasn't there. I mean, actually, we can get rid of that. That's true. Do that one more time. And come back. And this looks quite nice. Whereas the graph that we had before, I mean, this wasn't the exact one, but you see that there's all these swooping arrows down to C. And I would prefer that, C be simpler so that, it's maybe only dependent on stuff up here. So then kappa can be dependent on C. And I mean, technically, if we go here and we go back to Chris's site, you can see that all of these are reducible to be spelt just in terms of S and K. But, this is obviously overwhelming. So that's kind of a non-answer answer. Still going. What has that been, 5 minutes? I mean, this is why we need to parallelize it. Still going. Well, we'll wait 4 more minutes max. Otherwise, I'm just going to let this run in the background. Any other questions folks has? Thanks for the explanation. So I guess it could look like a tree. Yeah, potentially. What's my personal favorite research area? The intersection of combinatory logic and programming languages. And specifically, I think array languages, but not necessarily has to be. In fact, it's actually, I would say it's collection-oriented programming languages, which is a term that not many people know of. But I came across it when reading a paper by Guy Blelick. And you see here that several noticeable subcategories of collection-oriented programming are array languages, aka APL, database languages, aka SQL. And it's this idea that you operate on collections. So it's kind of like a sibling paradigm to functional, but functional talks about referential transparency and immutability and blah, 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 pure functions. But this has nothing to do with that. This is just that you have containers or collections and you operate on those containers. So like a language like Smalltalk would fall into this. Smalltalk is a collection-oriented programming language, even though it's completely not functional. It's, you know, the most object-oriented language there is. Maybe save for Simula 67. And yeah. Paul says, explain your PhD. I am not currently chasing a PhD. Maybe at some point in the future, but yeah. All right, we got 2 minutes left for this to finish running. Otherwise, we're calling it. I don't remember it taking this long. But then again, I did add like this many things, so this probably increases the runtime by a significant amount. What is it, Saturday? Let's go. Let's go solve a problem, if it's interesting. Because I don't think I looked at the Perl Weekly Challenge this week. You are given an array of words. Write a script to print all the words in a given array that can be typed using alphabet. Can be types using alphabet on only one row of a keyboard. Interesting. All right, we can go solve this while we wait. Should we do it in APL? The answer is yes, we should. I mean, we could also do it in BKN, but so this is our test case. And I think these need to be single quotes. Still not done. Let's see if we can solve this before it finishes. So we need, I don't want to type this out, although it's going to split it. It's kind of irritating. Come on. So first thing we need to do is we need to quad C everything. Which makes it lowercase. And in fact, actually, we don't need to do this. We just need to... And does it actually work on a whole string? Oh, look at that. Don't even need to do each. That's quite nice. And let's call this rows for simplicity. And how do we do this? We want to, for each word. So I think we need to box rows and then membership or something like that. Might take me a couple times to get this. Actually, let's do it over here. And then do we need to permute that? Waha. So that worked. And to show this off a little bit better, we've now got each of our strings, and we are checking membership for each of those strings in each of our rows. So we're going to get back a Boolean mask, which is the length of each of our strings. And it's going to give us whether or not it exists in a row. And basically what we just need to check is we're going to do a and reduction. And then an or reduction. And then now that we have that mask, we are just going to do a aha. And then we do that. Actually, how do we... I mean, it's a little bit irritating. I guess if we do that. Nope. What is unbox? Is it not unbox? Still going. How do we get rid of I mean, technically there's still empty lines here, but it's close enough. It's pretty good. A pretty good solution. What's the other problem? Yeah, I didn't explain that very well. Basically, we've got membership, and we're checking if each letter exists in the rows. And then you end up with this 3 by the length of your string matrix, where you want a single row to be complete ones. And you check that by doing an and reduction. And so the only way you get back a 1 is if every single value is a 1. And then you do an or reduction across your and reductions, and you're expecting it, you can type it on one row, at least one of those rows to be 1. And so as long as one of them is 1, you're good to go. And then you just need to find a way to filter. So this is called replicate or compress. And you put the mask on the left and your input on the right. But we can do that by just building it out on the left and using the C combinator. So this is the C combinator. This is the C combinator. What problems are array languages not good at? I mean, none. That's the thing, is like this is a very array problem. You're checking membership on strings. But Boolean indexing. Yeah, that's I don't know how do you do, I don't know how to do select. I know that there is some way to do like indexing. I think actually first what you'd need to do is you'd need to why doesn't that work actually? Isn't it where? What is where? I have no idea why this is. That should give me back 2, 3. Instead it's giving him back this nightmare of a... Oh, right. It needs to be on the outside. That's why. And you could, I think, do something like this. Anyways, we don't need to solve that. Let's check. Are we done? Still not done. All right, we'll solve maybe one more problem if it's interesting. You're given an array of integers containing citations a researcher has received for each paper. Write a script to compute the researcher's H index. Okay, I'm not doing that. All right. I think we're going to call it there. We've waited an extra 15 minutes, but this program's still running. So I'll post this on the GitHub repository once it shows up. But thanks for tuning in. Oh, wait, there's been some questions. When is the collaboration with Primogen happening? I did see that video. Primogen C to C++ to Rust. Yeah, where he reacts to one of the videos I made. It's somewhat entertaining. I don't know. I guess I mean, he hasn't reached out, so I guess I'd potentially be open to doing a collaboration. He has a much different style. He's more of like an entertainer, though. I'm quite dry. My content is quite dry compared to his, so yeah. And I did actually consider doing a live reaction to a live reaction. I laughed quite a bit. There are some things that he asks during the video. Like at one point, I use RV as the shortcut for the namespace std : views : ranges. And that's kind of motivated by two different things. One is that std : views : ranges, or no, std : views is a shortcut for std : views : ranges or something like that. So there is actually like a hidden ranges there where it's like ranges : views. And also it was initially the range v3 library, and I think it was pretty common to use RV as the namespace there. And I think SV, like standard views, is less indicative that it's like rangey. But there was a couple other things that he commented on that would be worth, I think. It would be educational if he ever watched it again. You could just go on an infinite loop. But yeah. All right, that was the last question. Thanks for Thanks for tuning in, folks. We'll probably do one more of these, but we're very close to sort of being done my goal. The only other thing is trying to get these things simpler and completing this table, but we're almost there. Anyways, thanks for tuning in. Hope you learned something, and we will see folks in the next live stream. Bye.